am Professor Thompson, and welcome to Chapter 5 of Math 172, An Introduction to Trigonometric Functions. We will begin by talking about angle measurements. An angle is made up of two rays that share a common endpoint called a vertex. An angle is created by rotating one ray away from a fixed ray. The fixed ray is called the initial side of the angle, and the rotated ray is called the terminal side of the angle. A ray rotated in a counterclockwise fashion has a positive measure. An angle rotated in a clockwise fashion has a negative measure. An example of both is provided. An angle is in standard position if the vertex is at the origin and the initial side of the angle is along the positive x-axis. The terminal side will always lie in one of the four quadrants or on the axis. An example of an angle with a positive measure, an example of an angle rotated clockwise with a negative measure. In trig, there are common angles, both positive and negative, that you should learn. They are provided here. Angles in standard position having the same initial side and the same terminal side are called coterminal angles. An example of a coterminal angle, a 45-degree angle, 405-degree angle, along with another coterminal angle measuring negative 315 degrees. Coterminal angles can be obtained by adding any non-zero integer multiple of 360 degrees to a given angle. In formula form, theta represents the angle measure plus k, any integer, times 360 degrees. Example, finding coterminal angles using degree measures. Find the angle of least positive measure that is coterminal with negative 115 degrees. So, adding 360 degrees to negative 715 degrees one time, we are still in the negative. We have not arrived at a positive measure. However, if we add 360 degrees twice to negative 715 degrees, we are in the positive, and we have the least positive measure that is coterminal with negative 715 degrees. Example, determining whether the angles are coterminal. This time we're given a 744-degree angle and a negative 336-degree angle. These angles are coterminal because we can multiply an integer, not a fraction or decimal, but an integer times 360 degrees and add that product to negative 336 degrees and arrive at 744 degrees. So, in summary, since negative 336 degrees plus 3 times 360 degrees equals 744 degrees, the angles are coterminal. Converting angle measurements in degrees and minutes to decimal degrees by cross-canceling units. So as a reminder, of course, 1 degree equals 60 minutes. Example, we are given 45 degrees and 6 minutes. We're asked to express this entire amount in degrees in decimal degrees by canceling units. So 45 degrees is already in degrees. We do not have to do anything with that. However, the 6 minutes must be converted to degrees. So 6 minutes times our fact of 1 degree equals 60 minutes, written as a fraction so that we can cross cancel out minutes, leaving us with only the unit of degrees. So 6 minutes is equal to 6 over 60 degrees. And when we divide that, it is equal to 1/10 of 0.1. So a final answer of 45.1 degrees is what 45 degrees and 6 minutes is equal to or equivalent to in decimal degrees. Converting angle measurements in degrees and minutes to decimal degrees by cross-canceling units. This time, our example requires us to convert -5 degrees, 45 minutes, and 30 seconds to decimal degrees. Another fact we need to recall is that 1 degree is equal to 3,600 seconds. -5 degrees, again, that is already in degrees. We do not need to change anything. However, the 45 minutes along with the 30 seconds must be converted to degrees, to decimal degrees. So 45 minutes, just as the previous problem, times the fact that 1 degree equals 60 minutes, written as a fraction, cross-canceling the minutes, we see that that's equal to 45 over 60 degrees. Moving that amount to our final answer. Now converting 30 seconds to decimal degrees. The unit fact here is that 1 degree is equal to 3,600 seconds. The seconds, that unit cross cancels, telling us that 30 seconds is equal to 30 over 3,600 degrees. Of course, converting the fractions, if you desire, to a decimal and adding all three amounts, we get a final answer of -5.7583 degrees. Now we are converting in the opposite direction. So we're converting decimal degrees to degrees, minutes, seconds. The procedure is still the same. Cross cancel units. You always want the unit you're going away from to cross cancel out. So converting 122.786 degrees to degrees, minutes, seconds, multiplying the 0.786, that decimal amount, by the fact that 60 minutes make 1 degree, letting the degrees cross cancel, we get 47.16 minutes. We now have 122 degrees and 47 minutes. So now we have to convert the 0.16 minutes to seconds. That's not a full minute, so it has to be converted to seconds. So 0.16 minutes times the unit fact that 60 seconds make a minute. Minutes will cross cancel out, leaving us with 9.6 seconds. 9.6, of course, rounds to 10. So a final answer, 122 degrees, 47 minutes, and 10 seconds. Radian measures. 1 radian is the measure of a central angle that has an intercept arc equal in length to the radius of the circle. S is the variable that represents the length of the intercept arc. You can see that arc here in blue. And again, 1 radian is the measure of the central angle that has an intercept arc equal to the length of the radius of the circle. So, understanding the relationship between degree measures and radian measures. 360 degrees, a full circle, in radian is 2 pi radian. A half a circle, 180 degrees, in radian measures would be pi. All of our common angles, again, which you should learn, learn have measures in degrees, which has been shared with you, and also in radian. You should also learn the measures of common angles in radian, and they are provided here for you. Converting between degrees and radians. To convert degrees to radians, multiply by pi radians over 180 degrees. To go in the opposite direction, to convert radians to degrees, multiply by 180 degrees over pi radian. So here are examples of converting from degree measures to radian measures. Looking at example A, to convert, as you see, 55 degrees to radian measures, we multiply by pi radian over 180 degrees. Numerator with numerator multiplying, 55 degrees times pi, or 55 times pi is 55 pi. Understood denominator 1 times 180 gives us 180. Simplifying the fraction for a final answer of 11 pi over 36. A second example is also provided if you would like to take a look at it. Examples of converting from radian measures to degree measures. Looking at example A, we are given 4 pi over 3 radian. To convert this to degrees, of course, we must multiply by 180 degrees over pi radian, with fractions multiplying straight across. We get an answer of 720 over 3. Of course, the pi cross cancels out, leaving a final answer of 240 degrees. Other examples, or another example is here if needed. Finding coterminal angles using radian measures. So to find a coterminal angle using radian measures, the formula is the angle measure represented by theta plus k, that's the integer, times 2 pi. Finding coterminal angles using radian measures. Some examples: find 3 angles that are coterminal with the angle pi over 6, using k equals 1, -1, and also k equals 2. I will talk about one of these examples. So starting with pi over 6, if k is 1, then we are adding to pi over 6 1 times 2 pi. Of course, when adding fractions, we have to have a common denominator. So 2 pi, that must be expressed as 12 pi over 6 to have a common denominator. And then adding your fractions, once you have that common denominator, your final answer will be 13 pi over 6. And our last example, or type of problem, finding coterminal angles using radian measures. This time we are asked to find the angle of least positive measure that is coterminal with theta equals -25 pi over 6. Of course, plugging in 1 for k, we still have a negative angle measurement. Moving forward and plugging in 2 for k, we still have a negative angle measurement. However, when we plug in 3 for k, we finally have a positive answer, and of course, it is the smallest positive measure, making 11 pi over 6 the final answer.